Here's an additional clip, if you will. I know it's been a lot. Roxy's been working hard, getting some exercises ready for you, or helping me piecing together some examples. I wanted to point out a couple of things. You will find in this week's folder two subfolders. I don't usually do that, but two subfolders. One is called Work on Your Own, Pearson's R and Scatterplot Example 2, and Work on Your Own, Pearson's R and Scatterplot Example 3. Example 1 was simply what we walked through on the YouTube clips in terms of introducing scatterplots and calculating Pearson's R. This is one of the items in the subfolder. In fact, it's one of the items in the subfolder called Work on Your Own, Pearson's R and Scatterplot Example 2. This is just a blank scatterplot. As you can see, it's hand drawn, and I have placed along the x-axis tick marks, or if you like, orientation marks to help guide you when you plot the data. Likewise, on the x-axis, there are orientation marks as well. And I've tried to scale those orientation marks to assist with what's referred to as the plotting of data. There is no secret or magic to plotting data. It's simply place a dot, hopefully an indelible, obvious dot, where the data point belongs. So when you get into that subfolder, you'll see an example that you can walk through to test yourself when calculating Pearson's R and creating a scatter plot. So what I'm referring to is, for example, as you can see, the x-axis on this example is education in years, with a low of 0 and a high of 25 years education. And then y y is income in thousands, and we have a low, likewise, of 0 and a high of 70,000. This scatter plot, perhaps obviously, is designed to help investigate the relationship between education and income. So for example, let's say somebody had, and go ahead and take notes if you have a pencil handy. Let's say someone had 10 years of education and they earned $30,000 a year. Okay, I'm going to say that again, more slowly. 10 years of education, that's our X variable, and $30,000 a year is their annual income. If I were to plot that data point, 10 years of education, 30,000 years a year in income, it would look approximately like that. It's not exact, but it's close enough. Another data point. Let's say somebody reported having 20 years of education and earning $60,000 a year. So again, the data point, or the coordinates, to use a term we were using a little bit ago, the coordinates are 20 years of education, and did I say 60? I think I said 60,000. So I'm going to go ahead and plot that one just to show you how it's done. 20 years of education, 60,000. That's what that would look like. 20 years of education, $60,000. All right, one more. Let's say someone reported having 15 years of education and earned $70,000 a year. 15 years of education, our X value, and $70,000 a year, our Y value. All right, that plot, or that data point, that data point would look like that. So that's plotting data. Okay, now I wanted to cover another item, another item in this segment, and that is problem set number 3. If you haven't yet downloaded and printed problem set number 3, you might want to do that. Fairly straightforward problem set, although it is quite lengthy. Basically, what I'm asking you to do is calculate Pearson's R for 3 sets of data, and likewise plot 3 sets of data, and interpret the relationship. All right, so be sure that you've read all of Chapter 5 and also reviewed all these YouTube clips as well. You will see, however, this is page 1 of problem set number 3. You will see at the top of page 1 that I present you with 3 hypotheses. And as I mentioned in a previous segment, we haven't really talked much about hypotheses yet, although we will. Hypotheses and the testing of hypotheses is going to become a pretty important topic for us in relatively short order. However, if you look at the top of the page 1 of problem set number 3, the directions, which I know you can read, but I'll go ahead and read them for the sake of this segment. Following these cover pages are 6 more pages representing worksheets pertaining to 3 bivariate, bi meaning 2, variate meaning variable, 3 bivariate analyses. The 3 bivariate analyses are labeled number 1, number 2, and number 3, and they correspond with the following hypotheses. Hypothesis number 1, H sub 0. H sub 0. H sub 0 is simply a symbol, or H sub 0 is simply a symbol for the null hypothesis. And when it comes to Pearson's R analysis, the null hypothesis is the hypothesis of no relationship. That's what we're testing, whether or not there is a relationship. So we're going to test the hypothesis of no relationship. Null hypothesis number 1 is there is no relationship between math scores and verbal scores. Null hypothesis number 2, there is no relationship between the age of a tadpole and the length of its tail. Null hypothesis number 3, there is no relationship between time spent watching television and time spent reading. I've included a number of instructions. However, everything that you're being asked to do within the context of this problem set you have had access to previously through this week's activities, and also has been covered, at least in part, in these YouTube clips for this week. Please heed all the instructions. That's very important, and also please be very neat. For example, here is item number 1 from the problem set, or the data for your first task. So here you have, I restate the null hypothesis. There is no relationship between math and verbal aptitude scores. And here I have a number of people, 11 people provided us with information. In fact, 11 people provided us with 2 pieces of information each, their math score and their verbal score. Math score, verbal score. So as you can see, person number 7 has scored 11 on math and 9 on verbal. Person number 10 scored 12 on math, 10 on verbal. Person number 1 scored 14 on math, 12 on verbal. And then you get to take it from there. You get to calculate means and standard deviations. You get to calculate x times y and add it together. Then you get to plug all that into the Pearson's R formula and solve accordingly. Then you get to take these raw data right here. You get to take these raw data and plot them carefully and neatly. Please feel free to print out multiple copies of this problem set, and that really goes for any worksheet and any problem set and any homework or exercise that you're asked to turn in. Print out multiple copies. Treat one like a scratch, treat the other like a final copy. Make sure that what you're turning in is very neat and legible, because if I can't read it, I can't grade it. Okay, one other thing. You probably saw this in your very close and meticulous read of Chapter 5 of Spats in the 8th edition. But some scholars feel as though Pearson's R is too lax or too liberal of a measure of association or test of a relationship. And so those scholars, statisticians, would argue that what we really need to do in order to be more conservative is to calculate what's referred to as the coefficient of determination. The coefficient of determination is simply R squared, Pearson's R squared, or Pearson's R times itself. That is the coefficient of determination. And that's considered a more conservative measure of the relationship between 2 variables. So for example, if we went through the math and calculated Pearson's R to be 0.50, 0.5 times 0.5 is 0.25, a more conservative estimate of the relationship between two variables. So that's it for now. I know that's a lot of information. Next week, I believe you're going to have your first exam. I'll send out some more information regarding that in relatively short order, probably later on this week. So in the meantime, happy reading, happy calculating, and thank you for paying attention, and thank you for being neat. Be as neat as you possibly can. Choxy says hello.